Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today's discussion will be about the isometric projections of the standard shapes, and these basic shapes, they will be used to draw different types of solids in the engineering drawing. And these basic shapes, they include square, rectangle, triangle, circle, pentagon and hexagon. So these basic shapes we are going to draw in three orientations. The first orientation is the horizontal face. So whenever we are going to draw these shapes in the horizontal face, then you see we are going to use these two planes over there. That is, we are going to use X and the Z dimension over there to draw the basic shape of this particular plane surfaces over there. And once we draw these shapes onto the base basically, and the height of the solid will be drawn thereafter, which will give us the completion of any type of prisms or the pyramids which are resting on their base. So the base will be containing the basic shapes over there. Then the second type of, you see, shapes which we are going, they will be corresponding to the left hand vertical face. So in the left hand vertical face, so we will presume that the solids, they are resting with their axis parallel to the ground, and then their basic shape, they will be drawn along X and Y dimension over there. So X and Y dimension, they will house the basic shape, that is either square, rectangle, triangle, circle, pentagon or a hexagon. So they will be drawn along this particular face of the 3D projection, and the depth of the solid will be drawn on this side. Similarly, the third type of the projections we are going to pick up, they will be corresponding to the right hand vertical face over there. So these are those solids in which their basic shapes, all these shapes, they will be drawn on the right hand face over there. So on the right hand face, that is, we will be making use of Z dimension and we will be making use of the Y dimension to draw the basic shape of the plane which is going to form the one edge of the solid, and then the depth of the solid will be drawn along this side. So in the horizontal face, you see the height of the solid will be moving upwards, whereas the basic shape will be drawn onto the ground. In the case of left hand face, the basic shape will be drawn on the left hand side plane and the depth will be shown on this side. Similarly, for the right hand vertical face, the shape of the basic plane figure, it will be drawn on the right hand face of the 3D projections, while the depth of the solid will be drawn on this particular side over there. So let us start with the first shape. So the first shape is about the square. Now we must remember that the dimensions, they will be foreshortened in the case of isometric projections. And another thing we must remember, that square, whenever we draw a square onto the isometric projections, we do not get to see the perfect square in the isometric projection, because we have discussed this thing in the previous lecture, that the shapes and the angles, they are not preserved in the isometric projection. So since we have to draw, you see, both of these projections, that is the two axes, the Z axis and the X axis, they are both lying at an angle of 30 degree. So that is why whatever basic shapes we are going to draw, so they will get somewhat distorted while we are going to project these shapes onto the isometric projections over there. So as I told you, this is the perfect square which we intend to draw in the isometric projections. So in the three orientation, so the first orientation is this one, horizontal face. So here in this case, we are going to assume that our prism or our pyramid, it is resting onto the ground on its base, right? So then the vertical side will represent the height of the solid, and the basic shape, that is the square, will be drawn using the X dimension as well as the Z dimension. So since it is a square, so the edge of the square is given to us as 30 millimeter. So this, you see, edge AD, it will be 30 millimeter, and then this will also be 30 millimeter. And then once we draw these two edges to begin with, then this edge will be drawn parallel to the edge AB, that is the edge DC will be drawn parallel to AB, and the edge CB or BC, this will be drawn parallel to AD over there. So this will give us the completion of the square as it is resting onto the ground. So we call it horizontal face. Similarly, the left hand face, you see, we draw the vertical height, that is the y-axis over there. Again we draw the x-axis. So x-axis is there, y-axis is there. On both these axes we are going to mark the lengths of the edge of the square. So once we mark the lengths of the edge of the square, which is again equal to 30 millimeter, so we get the two edges of this particular square which are oriented towards the left hand face over there. Okay, so then corresponding to AB, we are going to draw another line which will be DC, which will be parallel to the edge AB over there, and such lines, they are called isometric line. So all the lines which happen to be parallel to the isometric axis, they will be called isometric line. So here once again BC, so BC again we will be drawing parallel to AD. So BC and DC, they are both isometric lines, whereas AD and AB, they are lying on the isometric axis. Okay, so AD and AB, they are lying on isometric axis, whereas BC and DC, which are drawn parallel to AD and AB respectively, these two lines, they are called isometric lines because they happen to be parallel to the isometric axis. Similarly, over here also these two lines, they were isometric lines, whereas edge AD and edge AB, they are contained by the isometric axis. Okay, now we have the right hand side vertical face. So in the right hand side vertical face, we draw one vertical edge and another one towards the Z axis over there, because the right face we have to draw over here. So once again we are going to draw Z axis, and we are required to draw the Z axis over here and Y axis over here. And once we draw Z axis over here and Y axis over here, once again we are going to cut 30 millimeter on either side. So we get two edges of this particular square over there. Then using the principles of isometric lines, so AB will be parallel to DC. So through D, again a parallel line will be drawn which will be parallel to AB, and through B we are going to draw a parallel line, that is BC, which will be parallel to the axis edge over here, which will be AD. So this way the right hand vertical face square, left hand vertical face square, and the horizontal face square can be drawn. And in all these three cases, you see all the four edges, they are equal. We have tried to draw the square over there, but what is the, you see, internal angle of a square? It is equal to 90 degree. So do we find 90 degree angle over here? No, the angle 90 degree is not preserved in this particular case, even though we had drawn all these four edges equal to 30 millimeter. And since we are drawing the isometric projections, so one thing must be remembered, that whenever we say that we are going to draw the isometric projection length of 30 millimeter, it's not the true length we are talking about. So true length we have to mark onto the isometric scale, and once we draw the true length, then the vertical projection needs to be drawn onto the isometric length scale over there, and it is this length that we are going to talk about. So whenever we say 30 millimeter is the edge of the square, so we are talking about that we are going to draw isometric distance of 30 millimeter all across all these dimensions over there. So this dimension will, you see, it is approximately 82%. So this will be 24.6 millimeter. But even though we are going to draw it 82% everywhere, we have to mark this dimension as original dimension, which will be equal to 30 millimeter. So let us see how we can go about construction of the square shape in all these three orientations. Okay, now we are going to look at the construction of the square into these three orientations. So one thing we must remember, that every time any isometric projection needs to be developed, First of all, isometric scale I need to draw. So once I draw the isometric scale, only thereafter whatever original true lengths are given, so corresponding isometric lengths they will be evaluated, and all those isometric lengths they will be further transferred onto the isometric projections over there. So let us see the procedure of construction of the isometric projections of a square of edge 40 millimeter over here. So you see this is my square, right? So the both the edges they are equal to 40 millimeters. Step 1, I will be going for the construction of the isometric scale. So once I construct the isometric scale, I'll mark this 40 millimeter over here. From this 40 millimeter, now the isometric length corresponding to 40 millimeter will be worked out. This will be 32.8 millimeter. So once I measure this length isometric, so on the isometric scale it represents 40 millimeter, but practically on the true scale it measures to be 32.8. that is isometric dimension is equal to 82% of the overall dimension. Now let us draw the square in the horizontal position. So in the horizontal face, as I told you, the basic ground line will be drawn, that is the horizontal ground line will be drawn. We are going to mark a point over here. After marking a point over here, first of all x-axis will be drawn and the z-axis will be drawn. Just see, x-axis has been drawn and the z-axis. Then we are going to mark 40 millimeter, that is isometric 40, not the true 40. So isometric 40 we are going to mark on both the x-axis as well as the z-axis over there. So just see, on the z-axis I have marked at 40 and the dimensioning has been done. Similarly on the x-axis 40 millimeter isometric has been marked over here. Now the two edges they have been obtained. Now the remaining two edges they will be parallel to these two edges over there. So these are two edges of the square lamina which have been drawn onto the isometric x-axis and the z-axis. Now the two isometric lines we have drawn, this line is parallel to this edge. Similarly, this edge of the square is parallel to this edge. And once we draw this, now we can work out the center point. So midpoint of this edge gives us this axis line. Similarly, midpoint of this edge gives us the construction of the axis line. So this is going to be my center point, because usually these figures I am going to use in order to construct prisms and pyramids over there. So the axis construction is mandatory. And another thing we need to remember very importantly, that angles they have not been preserved in the case of isometric projections. So the 90 degree which used to be here, it gets distorted. So angles are distorted. And another thing, in case of any square, the two diagonals happen to be equal. So the diagonals of the square, they are equal over there, and moreover they are at the 90 degree angle. Whereas in this case, while we draw the square onto the isometric projections, so we will find that the two diagonals of the square, you can check, this is diagonal 1, this is diagonal 2. Both of these diagonals, they are not equal to each other. And since these diagonals, they are not equal to each other, so this characteristic makes this figure which we have obtained corresponding to a square to be a rhombus. So we can say that square appears like a rhombus in the isometric projection. So this was the horizontal face. Now we are going to draw the right hand face. So right hand face means on this side and on this side. On the y-axis and on the z-axis I have to carry out the construction of this particular square. So once again I'll draw the basic isometric axis over there. This is x-axis, this is z-axis, then I will be drawing the y-axis as well. So on the z-axis you see I have marked 40 millimeter. On the z-axis I have marked this isometric length of 40. So the true length will be 32.8 millimeter over there. And once I draw this isometric length equal to 40 on the z-axis, now I need to draw the y-axis. On the y-axis, once again the same length, because in square both the edges they are equal. So this edge length is also equal to 40. So this edge of the square is resting on the isometric axis. Similarly, this edge of this isometric square, it is resting on the isometric axis over here. Now, the remaining two edges of the square can be worked out by drawing two isometric lines parallel to the existing edges of the square which we had obtained previously. Now you see, this edge is again parallel to the isometric axis, so this is the isometric line. Similarly, the length will be again 40 millimeter, and similarly this edge, this will be parallel to this one edge. So these two lines or the edges, they are called isometric lines of the projection, right? So these are first two edges which are lying on the axis, whereas these two edges, they are the isometric lines because they happen to be parallel to the isometric axis. Now in the third orientation, you see this is the axis, and once again you see there is one longer diagonal for this particular rhombus and there is shorter diagonal for this rhombus. So even though we have tried to draw a square in the isometric projections, but it violates the basic principle that the angles, they are not preserved and the diagonals, they are also not equal over there. So this shape becomes a rhombus. So we will say that whenever we construct square in the isometric projections, we are going to get a rhombus over there. Then the third one, left hand face. So in the left hand face, once again we have to use the left face over here. We have to look from this side. So the x-axis will be used and y-axis will be used. So first of all, 30 degree, this is your x-axis, this is your z-axis. Now we mark 40 millimeter on the x-axis now, and then draw vertical axis, that is y-axis, again mark 40 millimeter. So the two edges, they have been obtained onto the axis, isometric axis. Now two isometric lines will be drawn, that is this edge will be drawn parallel to this one, again length will be equal to 40 millimeter, and the fourth edge will be drawn parallel to this isometric axis over there. Now we get the square construction, and once again the center points, axis points, they have been located. Get the midpoint of this, get the midpoint of this. Similarly, getting midpoint of this and getting midpoint of this will get the second part of the axis. So this is our center point. Now once you join both of these diagonals, so once again we find that there is one longer diagonal, there is one shorter diagonal, and this is the characteristic of a rhombus. So again, in all these three orientations, you see it is horizontal face, this is left side facing, this is right side facing. So we have made the construction of a square. Now the next one is rectangle. So it is just similar to the square. There is only one difference, that in rectangle one edge is bigger than the other one. So there will be one shorter edge and one longer edge will be there. So construction procedure remains the same, that is top facing will be there, that is horizontal face. So we are going to use in the horizontal face x dimension and z dimension. So the height will be shown over here. Then in the left hand face, we are going to use the x-axis and the y-axis to get the construction, so that we can look at this surface from this side, and the depth will be drawn on this side over here. Similarly, the right facing, we are going to use the z-axis and the y-axis to complete the construction of this figure of the rectangle, and then we can look from this side, and the depth of the solid, that is the prism, we are going to draw onto this particular orientation, right? So let us start drawing all these rectangles in different orientations. So once again, as usual, start with construction of the isometric scale. And now once we have drawn the scale, now we have to start with the horizontal face. So in the horizontal face, we have discussed that two axes, basic axes we are going to use, that is x-axis and this is your z-axis. So this is x-axis, this is z-axis. Now here once again we are going to do the marking. So any of the edges you can place here. Let us say I place 50 millimeter edge over here. So 50 millimeter edge of the rectangle has been placed over here. So this is 50 millimeter and this edge, this is 40 millimeter, right? So this is 50 millimeter, this is 40. So these two edges, they are lying on the isometric axis. And once we obtain these two edges, next we have to draw the isometric lines over there parallel to this one. So this edge will be parallel to this one. Length of this edge will be 40 millimeter. We have to draw this edge parallel to this one, right? So length of this edge will be 50 millimeter. If this is 50, this will be 50. If this is 40, so this edge length will also be 40. Now we can darken them. So this gives us the construction of the rectangular shape onto the isometric projection, whereas it is facing the horizontally, so that the height we can plot on this side. Okay, see, height of the object, whether it is a prism or a pyramid, will be drawn on this side. Next one is left hand vertical face. So left means we are looking from left side. If we have to draw left hand face, so two dimensions we are going to use, two axes. This is our x axis, so this and the y axis. So z axis will not be used in that case. So z axis will be used to show the depth of that solid. So right now we are trying to draw a two-dimensional figure, so only two axes will be required. So once again, the basic shape 50 millimeter will be drawn over here onto the x-axis, and onto the y-axis you see the 40 millimeter height we have drawn. So this is my height of the rectangle, which is equal to 40 millimeter. So height of the rectangle equal to 40 millimeter has been drawn on the y-axis, whereas the length 50 millimeter has been captured onto the isometric axis, that is in the x-axis direction. Then once we draw these two edges, then this edge will be drawn parallel to this one, and this edge will be drawn parallel to this one, such that the length of this edge is 50, so this will also be 50. Height of this edge is equal to 40, so height of this edge will also be equal to 40. Now we can join the edges dark and work out the center point. So center point will be midpoint of this, you join the axis line one half, then midpoint of this and midpoint of this, and this will give you the axis point, right? So this is the left hand vertical face. So we are looking from the left, and the depth will be shown if required on the other side. Okay, next one is right hand vertical face. So in the right hand vertical face, we are looking from the right side. So we require over here z-axis will be required, and the y-axis will be required. So it's a two-dimensional shape. So right now we are not going to use x-axis. X-axis will be used to represent the depth of the solid. Now let us draw the lamina over here, or the plane figure. Now the height is equal to 40 millimeter, and the length of this face, rectangular face, this is equal to 50 millimeter. So this edge of this rectangular lamina or the surface is going to rest on the z-axis, whereas the height, this will be drawn onto the y-axis over there. So y-axis 40 millimeter and z-axis 50 millimeter. Once we draw both of these, then these two isometric lines, these are the two isometric lines which can be drawn to complete the construction of this rectangular figure over there. So this is the construction of the rectangular face in all the three shapes over there, in all the three orientations over there. Now next we have the triangular shape, and while we are trying to draw this triangle, in this triangle the base edge is given to us, and the two angles of the sides, they are provided to us. But two things we need to remember while constructing the square and the rectangle. We have already observed that the angles, they are not, and the basic shapes also, they are not preserved or maintained in the isometric projection. So since the angles, they are not maintained, so in order to draw this particular triangle, in this triangle the base is given that we can draw, there is no problem regarding that, but there are two angles which are given. So since we cannot preserve these angles in the isometric projections, so what we need to do, we need to work out the rectilinear distances over there. I know this is my base, so this distance is given to me as 30, And once I do the construction of this particular triangle, I need to inscribe this triangle into a rectangular figure so that I can get the measure of the rectilinear distances from the point A and from the point B. Is that clear? So this is my triangle. I cannot transfer these angles directly in the isometric projections. So I am going to first of all carry out the construction of this triangle based upon the original angles over there. So once this construction is finished and triangle 1AB is constructed, then this triangle will be inscribed into a rectangular figure, whatever shape of the figure may be. So this is the rectangular figure which I am able to obtain. And once I have this rectangular figure available with me, I am least bothered about these angles now, because I have already gone about the processing of the rectangle in the isometric projection. So I know that this is my first dimension of the rectangle, which is 30. This is my second dimension of the rectangle, which is x, and the third dimension will be the location of the point 1. So I will be marking this one edge, second edge, and the third edge over here. The moment I mark these three edges, so these 3 points 1, A and B will be located onto this rectangular shape figure which I am going to draw in the isometric projection. So once I locate these 3 points 1, A and B, then straight away I will be joining 1A and B. So this will give me the construction of the triangle in the isometric projections over there. So once again, in the horizontal face, left hand vertical face and right hand vertical face, all these 3 triangles, they have to be drawn. So let us start working upon that. Step 1, you draw the isometric scale as usual. Once you draw the isometric scale, next step is start drawing with the construction of this triangle. So triangle I cannot draw. I have to first of all draw triangle over here in the true scale, right? So original true scale construction of the triangle has to be completed with the given angles over there, with the given dimensions over there. Once this is completed, now I have inscribed this triangle into a rectangle surface over there. So I can construct rectangle very easily. And once I construct this rectangle, I am going to measure this distance 1, distance 2 and distance 3. So these 3 distances once I measure, so automatically points 1, A and B, they will be located. So let us see how we can work upon the projections of the triangle in the isometric projection. So since this is the horizontal face, so the 2 axes which they will be used, they will be x-axis and z-axis over here. On the x-axis, I can keep my length equal to 30 millimeter. So the length of my rectangular face will be equal to 30 millimeter. So once I say this is 30, now this length I can draw, which is equal to x, because this measurement I have not shown. This may be 22, this may be 27, this may be 26, right? So whatever this is, so whatever is the measurement of this x, so this x will be drawn on this side. So the horizontal face is showing me 30, which corresponds to AB, and this vertical face, it is BC. So this BC face happens to be x. So this is my isometric axis, and these 2 lines, they are my isometric lines over there. So having completed this construction, now you see I am going to mark these points A, B. So AB is equal to 30, right? Then BC. So what is BC equal to? BC is equal to x. What is BC equal to? X. And then D. This is my point D. So I have located all the 4 points of the rectangle A, B, C, D. A, B, C, D. So AB is located. Now only thing is I need to locate point 1. So using rectilinear distances, please see again, I repeat, using rectilinear distances, point 1 has to be located. So how do I locate point 1? From B, you move towards C at a distance x. So from B, I have moved towards point C at a distance x. So all these distances, they are isometric distances. So once I reach C, so from C, I need to move towards the for a distance of y. This is my distance y. So I will be measuring the isometric distance y and mark a point over here. The moment I mark a point, this gives me location of point 1. And the moment I locate point 1, so very easily I can join 1 A and B. So this gives me the construction of a triangle in the isometric projection. And mind you, this angle will not be equal to 45 degree. Similarly, this angle between AB and B1, this won't be equal to 60 degree. So this is the shape of the triangle which will appear to us while we are looking at this particular lamina or the surface in the horizontal face over there. So let's draw it in the left hand vertical face. So once again a rectangle will be drawn, size 30 millimeter by x millimeter, 30 millimeter by x millimeter. So 30 millimeter will lie on the x-axis and x millimeter will lie on the y-axis. So this will give me the construction of a rectangle. So this is longer edge of the rectangle 30 millimeter. This is shorter edge of the rectangle which is x millimeter. So these are the lines or the edges of the rectangle which are going to lie on my isometric axis. Now two isometric lines I am going to draw, one and second. This is parallel to this, this is parallel to this. So once I draw this, I can mark all these points A, B, C, D. So all the 4 points of the rectangle, they have been appropriately marked over here. Now from B to C, I have marked X. From C to D, I need to mark the distance of Y. From C to D, I'll be marking the distance of Y. So I am moving from C to D. Whatever distance of Y is there on the true scale, this will be transferred onto the isometric length and this distance will be marked over here. So once I mark this distance Y, I get the point 1 over here. And the moment point 1 is located, so once again I can complete the construction of my triangle over here. So once again this angle won't be equal to 45, this angle won't be equal to 60 degree. So let us draw the third orientation for the triangle. So in the case of triangle, as I am trying to look from the right hand side, so these two axes will be used. What are those axes? Z axis and my Y axis. On the Z axis 30 millimeter length has been plotted, on the Z axis 30 millimeter. So please check, this is my 30 millimeter length, and on the Y axis x millimeter, whatever is this distance, x. So this x you mark on the true length, get the appropriate length on the isometric scale, and then draw the two isometric lines over there so that you complete the rectangle over there. Now once you complete this rectangle, A to B we have moved, B to C again we have moved, and from C to D this Y distance will be measured over here, right? So this will be marked, and the moment you mark this Y distance, now you can obtain the location of the point number 1, and moment the point number 1 is located, so the triangle 1AB, it will be completed. In this lecture we have discussed about the construction of the first 3 basic shapes which will be used in the isometric projections. That is, we have discussed about construction of a square, construction of a rectangle, and the construction of a triangular shapes in the isometric projections. So we will be continuing with further discussion on the remaining 3 shapes, that is circle, then we have the pentagon, then we have the hexagon. So these 3 shapes we are going to discuss about in our next lecture during this lecture series. So this is all for today. So thank you very much. Thanks a lot.